Now Juan's kind of looking through a microscope into what kind of looks like a clear flask with a little orange top on it.
Yeah, so that flask is a cell culture treated flask that allows adherent cell cultures to attach to the flask and grow as a monolayer on it. And it's vented to allow gas exchange between the environment and the flask itself. And if you look through the microscope, you can see our cells if you're interested.
That's scientist Juan Camacho of Gelotech. We're standing in his lab in Raleigh, North Carolina, where he's showing me his cultivated animal cells under a microscope. Next semester, UNC-Chapel Hill is offering its first cellular agriculture class. Students will learn about cell-cultivated meats and tissue engineering, as well as the economics of the cell ag industry. So, what I see are these kind of like, I don't know, it almost looks like striations, but I guess they're kind of long. They kind of look like hairs.
Not quite. They're fibrous.
They do look very fibrous. Kind of just looks like hair that has some kind of soap clinging to it. Where does our food come from? What about our skin creams? Health supplements? Gummies?
The absorbance values tells us how intense the dye is, and from that we use the equation to calculate the amount of collagen that was produced by the cells.
The sound that we just heard was Juan's microplate processor, a machine that tells Juan how productive his cell cultures are. Juan is growing collagen and gelatin in his lab from animal tissue samples. But what is Gelotech planning to do with these cultured cells?
I'm Rob Schutte. I'm the head of science at Gelotech. Our idea is that we will use cells that are from animals but can be obtained from cells in a way that is not harmful to the animal. And those cells can then be used to create collagen that can be used for biomedical applications, for cosmetic applications, food and beverage applications. And the model is really for sustainability, to try and eliminate the need for animal products to create collagen.
Collagen is an animal-based protein which can be used on its own or made into gelatin.
So I think there's a lot of food products that probably have collagen or gelatin in it, specifically like gummies, gelatin, like Jell-O. Anything that's kind of has that gummy texture probably uses collagen to achieve that kind of texture that you want. And then outside of food and bev, a lot of supplements are using collagen as well for just like dietary supplements.
Rob and Juan are growing their cells in an office building in Raleigh, North Carolina. Cellular agriculture is a growing field of science that could drastically reduce our dependence on livestock.
We're essentially using the cells as a factory to produce the collagen rather than relying on the entire animal. And we believe that we can find sustainability in models that use cells rather than the entire agriculture system required for animals.
Next semester, students at UNC-Chapel Hill will have an opportunity to learn about cellular agriculture, thanks to one group of impassioned students. I met Sophia Retchen at Open Eye Cafe in Carborough. I ordered a ginger root and black cherry kombucha, and she, well...
Can I please get a golden milk latte? Absolutely. With oat milk. Okay.
Sophia is a senior business and environmental studies double major at UNC-Chapel Hill. She's also co-founder and co-president of the Chapel Hill Alt-Protein Project.
We're one of about 20 alt-protein projects around the world now, all supported by the nonprofit The Good Food Institute.
Alt-protein, or alternative protein, is real meat produced through cellular agriculture. Sophia co-founded the Chapel Hill Alt-Protein Project with Diksha Mittal in the spring of 2020 to spread awareness about cell-cultured meat.
Our goal at UNC is to increase alt-protein curriculum because right now students aren't learning about this field, so how are they going to know that this is a great career path to go into?
But that's about to change. This spring, UNC students have an opportunity to learn about cellular agriculture in a new elective course, Biology 290.
We launched one of the world's first courses about alt-protein. We developed it in coordination with a couple of professors here, and it's going to start this January.
The course will host guest lectures with speakers from local biotech companies, as well as the Good Food Institute and New Harvest, a research institute for the advancement of cultured meat.
I'm hoping the class firstly inspires students to partake in this revolution. So even if the class influences just one student to dedicate their career to this movement, I think that's a massive success, because everyone has about 80,000 hours in their career. So if we just get one person to dedicate 80,000 hours to this movement, I think that is massive impact.
They recruited 3 professors to teach the course: Dr. Alan Jones, a Keenan Distinguished Professor of Biology, Dr. Andrew Gladden, an Associate Professor of Pathology and Lab Medicine, and...
My name is Doug Fansteel, and I'm an Assistant Professor of Cell Biology and Physiology at University of North Carolina at Chapel Hill.
Doug volunteered to teach Biology 290. Literally, the university is not paying him for the course.
My lab actually does genetics research, genetics of human disease, including Alzheimer's and osteoarthritis and leukemia. But I'm co-teaching this class in the spring, Biology 290, on cultivated meat, which I'm excited to teach. It's going to be the first time it's taught at UNC. So we're trying to make this class accessible to people from all majors in all grades. So I don't think we actually have any prerequisites for this class. I could be wrong about that. We hope people have some type of biology experience or class that they've taken, because it'll be kind of important to understand a class, but just a basic biology background is sufficient. So that's probably one of the main things we've changed is made it a bit less technical. We've also focused it specifically on cultivated meat. Some of the other classes were a little bit broader, covering plant-based and fermentation-based products.
The course has already demonstrated interest around campus. Sophia said spots in the class filled up in just over a day.
We were ecstatic that it maxed out that fast, because that shows that there's high demand. Originally we had a 30-person cap, and then I convinced them to increase it to a 50-person cap, and I tried to increase it to a 150-person cap, but they wouldn't let me do that. So we stuck to 50, which is still a solid amount.
I reached out to one of the 50 students who had enrolled in Biology 290 for next semester.
My name is Emily Barkley. I'm a first year. I am a pre-environmental health chemistry and chemistry double major.
A member of the Alt Protein Project came to Emily's chemistry class and talked about the upcoming course.
It seemed like a good way for me to explore chemistry and the impact of synthetic meat and just meat in general on the environment, so it just seemed like a good combination of my interests.
For now, Biology 290 is a special topics course, only guaranteed for the next semester. But Doug and Sophia are hopeful that cellular agriculture will find a permanent home in UNC's biology department.
We're not training students currently for these types of careers, or not specifically for these types of careers. So I think hopefully this is just the first step into more classes and whole curriculum, and maybe even majors that are focused more for students to go into this industry, so they'll get the proper types of training. We hope for it to become a permanent class that's taught every year. I can't say any more than that's all I know, is that we'd like it to be taught every year. But right now we're just going to teach it and see how it goes.
Our eventual goal is to have an alternative protein minor at UNC, because ultimately we believe that there really could be an entire major or even an entire department about alternative protein production.
If you're interested in learning about cellular agriculture, there are many ways to learn more.
I think the best way to get involved would just be to kind of like reach out to us or a company that is in the field and kind of just get a feel for, what they're looking for, what kind of skills are in demand, what kind of courses would be helpful to kind of help guide you into the field. But if you do have some lab experience from the start, I think that does help a lot if you're interested in more of kind of like the science side of things.
I think another opportunity for students to get involved in the cell ag industry would be to look for professional events, professional networking events in the Triangle area.
To learn more about cellular agriculture, I recommend checking out the Good Food Institute's website. They have really every resource you need for a Cell Ag 101 type spiel.
Yeah, well, I can make a pitch for my lab. We're looking for somebody to to work on replacing FBS in our cell culture systems. We probably will collaborate with some of the cultivated meat industry moving forward. So that's a small plug. But I know that there's a bunch of local companies that are always looking for people, possibly at the intern level or entry level positions. And this class could expose them to some of them. People can get involved with the Chapel Hill Alt Protein Project, of course.